Well, good morning, good evening, good afternoon to everybody in this class. Again, this is my kind of my second day of making these recordings, and I just want to say a couple of words as we start off right off the bat. I want to remind you the best way to learn math is, first of all, to write things down, to actually physically take your hands and write down the notes slowly, carefully, get everything on the page, because that way you're activating your brain, your body, your hands, your coordination, and you're recreating it. All the research says that's the best way to remember things. The second thing is, I just want to remind you that about every 10 minutes or so, I will say to pause things, stop the recording, and begin to do the home. I'll tell you which pages in the homework to do, and that's in your number power 4 geometry book. And do that homework, do all the exercises, then you can press play again and go on to the next section. That's the best way to learn. So the idea of taking careful notes, stopping when I say so, and then doing all the homework, those are what are called best practices for learning, especially for learning mathematics. Okay. So with that said, I'm going to jump into some things. So the first thing I want you to do is, and I'll make this larger, is I want you to pause the video. And there, this will be a, whoops, make it a bigger screen here. I want you to pause the video and to copy down what you see on the screen here. Okay. I'm going to start off and start talking about some of these complements. You know what? I see that my slide here, it looks like we are, let me just make sure we're on the right slide. Yep, we're on the right slide here. Okay. Um, the first term is called complementary angles, and I'm concerned that my little choices here on the left are going to cover this up, but I'll write it up. The first one is called complementary, and so this is how to spell it. Complementary angles. Okay, and so those are angles whose total is, if you add them together, it comes to 90 degrees. And so if I take a look at you'll see my diagram here that's got I've got angle QRS here on the screen, which I'm going to circle so you can see exactly what I'm talking about. This angle right here, QRS. Okay, that's a 90-degree angle. And if you look at the T here, if you look at angle TRS, okay, that's 38 degrees. Okay, complementary angles are angles that when you add them together, it comes to a total of 90 degrees. It equals 90 degrees. Okay. And so, and again, as a review from the last session, a 90-degree angle, we call it a right angle or a 90-degree angle because this is exactly 90 degrees. So complementary angles, okay, they're giving each other complements. I like to think of it, if I draw this out here in the on the side here, if I have this angle right here, that's kind of a little small one, okay, that goes from here to here, okay. The rest of it that goes all the way to 90 degrees is the complement or complementary angle. Those two angles are complements of each other, okay. So back on my what I've written here in white here on the screen here, angle QRT. So that's, if you go up and look at angle QRT, you can see that QR and T is a complement of angle TRS. The two together equals 90 degrees. Okay. So I've got an example question that you might run into, and that is find angle QRT. Okay, that's QRT, the top. Okay, if this should say if, okay, if angle TRS is 38 degrees, here's how you would do the math. I'll circle it on the screen so you're focused right on what I want you to be looking at here. So you would take 90, like 90 degrees, subtract 38 degrees from it, and you'll get 52. And that tells you what is left. Okay, you might remember that term for story problems. What is left? How many are left? So if I take the total minus what I'm dealing with, I get what's left. And so the answer is 52 degrees. So angle, if you look back at my diagram right here on the screen here, that I circled, angle QRT is 52 degrees. Okay, it is the complement. Okay, and sometimes I just think of them as complementing each other up to 90 degrees. Okay. All right. The next concept is what's called supplementary angles. And so supplement, okay, I'm going to write it out here in case you cannot see it on the screen because I'm not positive that it might be. They're called supplementary angles, okay? And they are, as you have copied down in your notes, angles whose sum or total, if you added them together, that's what sum means, is 180. Okay. So if you look over here at my diagram on the far left here, if you look at the line from B all the way to D, okay, that's 180 degrees, which we learned in the last session. A straight line, the angle all the way around it is 180 degrees from well, it's 180 degrees. So supplements are two angles that added together, they equal 180 degrees. Okay. So angle BCR, which if you look at my diagram here, BCR, okay, and angle RCD are supplements. Okay, not the type you take with little pills in order to stay healthy, but they are supplements of each other because they both add together to be 180. Okay. So here's an example of question here at the bottom left. Find angle BCR if angle RCD is 130. Okay, so they gave you 130 degrees in this angle here, this one here that I'm drawing an arrow for. They gave you this. So the math would be, we'd take our total 180 degrees, subtract 130 from that, which is what they gave us, and whatever's left is whatever is this 50 here is what's left here. Okay, it's what this angle is. So that's how you would find a supplementary angle. Quick review: complementary angles, two angles that add together to 90 degrees. Supplementary angles, two angles that added together equal 180 degrees or a straight line. Okay, so that's my first concept. I'm going to jump to the next concept, which is, all right, let's see here. See if I can get this to go. Come on. Okay, I'm there. All right. Vertical angles. Okay, so what I want you to do is pause the recording here, and then I want you to take a moment and copy down all these notes here, and then we'll continue, and I'll pause for 5 seconds while you do that. Okay. So the first, now we're talking about vertical angles. So the whole lecture today, the whole big picture is different pairs of angles that pair together, okay, and then some other concepts as well. But vertical angles are angles that are, as it says on the screen, across from each other, okay. When two lines cross, the vertical angles are equal. So what I want you to do is this is what are called my vertical angles here. They're across from each other. So come over here and look at the diagram on the right here that you have copied down here. You see how I've got numbers for my angles, angle 1, 2, 3, and 4. Angle 1 and angle 3 are vertical from each other. They're across from each other, okay? Likewise, angle 2 at the top is vertical to or across from angle 4. All right. So that's what it means by vertical. They're across from each other, as we put in our definitions here. They're across, okay? When two lines cross, vertical from each other. Okay. In addition, they are equal. So if you have two lines that cross, if I take my thing here, if I make it this X and I have two lines that cross, 1 is going to be equal to 2, and 3 is going to be equal to 4, okay? And so if over here on the far right, vertical angles are equal. So it says angle 1 is equal to angle 3 in the diagram above here. Okay. It's 50 degrees here. This angle 1 here is equal to angle 3. All right. And angle 2 is equal. So this is how we would write it down on paper. Angle symbol 2 equals angle symbol 4. Okay, so 2 and 4. And they're both 130 degrees. 2 and 4 are, 1 and 3 are 50 degrees, as you can see. Okay. I've got a little note here I want you to look at here on the screen here. And that note says, when two lines cross, each acute, remember acute is less than 90, okay, is supplementary to each obtuse angle. For example, angle 1 and angle 2 are 180 degrees. All right, let me just show you what that means so that you can understand those words there. If you go back up to my drawing here at the top right of the page where my arrow is pointing here, okay, what I want you to do is I want you to look at this line right here, okay? I'm just filling it in here. Just we're going to look at everything that's above that line here for a second, okay? And so what that is saying is that the acute angle 50, which is this one here, this angle here that goes from here to here, okay? This acute, remember, acute is less than 90, is supplementary to staying, we're looking at everything above this line here, to angle 2. 1 and 2 are supplements. And so if, for instance, they only gave you 50 and they ask you, which we're going to get to here, all the other angles, what they are, you could go, okay, well, the opposite of 50, opposite angle, okay, the one that's vertical from it would be 50. And if I know if this is 50, this first one's 50, one is 50. If I subtract that from 180, that would give me 130. And then I know that the opposite of side, the opposite or vertical angle to 130, which is angle 2, is angle 4. So that would be 130. So you could give me just one angle when you have two lines crossing each other. If you just gave me the measurement of one angle, you could just do the logic and figure out what all the other ones are. Okay. So that's what my little post-it note here means. Okay. All right. What I want you to do is when I'm finished with this slide, I want you to stop the recording and I want you to complete page 27 in your textbook. That's the number power 4 geometry textbook. It should be a purple color. And then start the recording when you've done those problems. Okay, I'm going to start back up again. We've got an example problem here, okay, on that I'm going to have you just kind of for practice get an idea of how to do these kinds of problems, okay? So this is my example problem with dealing with pairs of angles, okay? It's like a story problem. It says a ladder, okay, that's the type you climb up a ladder. A ladder here, okay, leans against a house. So I'm going to draw it here. Here's my ladder in red, okay? The ladder makes an acute angle of 61 degrees with the ground. So what that's saying is right here, where my arrow is drawing right here, this angle is 61 degrees from the ground to the ladder, okay? What is the measure of the obtuse, remember obtuse is bigger than 90, angle that this ladder makes with the ground? And so what it's actually asking is, what is the supplement of 61? Remember, with the ground, the 61 degree angle, what is the other angle that goes from here to the ladder? Okay, that's what this question is asking. What is the measure of the obtuse angle? That's the bigger than 90 angle that pairs with it, with the 61. Well, here's the math. You take 180 degrees, because that's what supplementary angles are. They add up to 180 minus 61, and you get 119 degrees. Okay. So you'll see some practice questions like that one in some of your homework. So wanted to cover that one. All right, let me go on to the next concept, which is, okay, here we go. Another example. All right, another sample problem. Ohio Street. Oh, by the way, go ahead and pause the video, copy this down, and then start the video again. I'll wait for 5 seconds. Okay, Ohio Street intersects with 7th Street as shown below. What are the measures of the 3 unmeasured angles? Now, I don't want you to be confused by this term measures. That means they're just asking for how many degrees. Okay, this term right here, if they ask you for the measure of something, they're asking for how many degrees it is. Okay, so it wants to know what the other 3 are. And this is what I just mentioned previously. Okay, we've got an angle here. We've got Ohio Street. That's the one that goes from the bottom left up to the right. And then you got 7th Street that crosses it. All we're given is this angle between them two of 48 degrees. Okay. And it wants to know the measure of um, angle, we'll call this angle 1. Okay. We'll call this angle 2. And we'll call this angle 3. Okay. What are the angles of these? All right. Well, if based upon what we just learned, we've got vertical angles. 48-degree angle is vertical from this angle 1 over here that I'm just filling in again. Okay. Okay. So, and the rule was vertical angles are equal. So if the first one's 48, that means one has to be 48. And again, you might as well practice writing this correctly on your paper. Degrees, that little degree symbol. Okay. All right. Can you guess how we can now figure out if this is 48 degrees here, angle 1 is? Can we now figure out what Ohio Street is? I'm sorry, what the angle is, which I'll draw here. What is this angle from here to here? Okay. They're supplementary. So here's the math to find out what angle 2 is. We would take 180, just going to write it over here on the side here, minus 48. Going to do the math here because that's going to give me, I'll just do this the old fashioned way here, 2, a 3, and a 1. Okay, that's 132. All right, that means that angle 2 is 132 degrees. And again, there's the little degree symbol. Okay, now by logic, we pause here for a second. We got to figure out what angle 3 is. Angle 2 and angle 3 are vertical. And we just learned that vertical angles are what? They're equal. So that must mean that 3 has to be 132 degrees. Okay. And we now know what all those angles are in this sample, this story problem. All right. After that's done, I want you to do problems, after you've listened to this, problems 3 through 10 on page 29 of your textbook. And once you've done problems 3 through 10, do all of them on page 29, come back and I will teach you some more. Okay, I'm back. All right. Hopefully you shut off the recording and you came back. All right, first thing you're going to do is you're going to take you're going to pause this recording. You're going to copy down everything you see on the screen. All right, let me talk about what this says here on the screen. All right, parallel lines cut by a transversal. Okay, so we've got some new words here, right? Parallel lines are lines that run side by side. They go across side by side. So if you look at the 2 lines A and B here, which I'm drawing an arrow towards, those 2 lines are parallel from each other. Okay, and it says that they do not cross at any point. And what that means technically is these lines, if I put a little arrow on the end of them, they would go on forever. Okay. Technically, if they're parallel, they would go on and never stop in both directions, but they would never meet because they're exactly parallel with each other. Okay. So that's kind of the technical physics of it, that 2 exactly parallel lines would never actually run into each other. All right. I want you to also note that there's a symbol for parallel lines. So I'm going to circle what I'm talking about right here on the screen here. Line A is parallel to B, so you would write A, and then the symbol is these two lines here. I'll just write it on the side here. Make it a little bit bigger than the actual letters. A is parallel to B. That's what the parallel symbol looks like. Okay, just like an equal symbol is an equal symbol straight across two lines, parallels up and down. Okay. All right, so that's what a parallel line is. All right. The next concept is a transversal, and that's just a third line that crosses the parallel lines. It crosses with them. So actually two parallel lines. So yeah, two parallel. That's TWO there. That's what a transversal is. That's just the name of it. So when you see it in your homework, if you see it on your first test, it's the line that crosses the two parallel. So on my screen, here's my transversal. Okay. All right. Those are those concepts. Moving on to the next slide. And all right, we're going to do a little bit of learn some things. All right. Again, I want you to stop the slide, stop the recording, copy down what you see on the screen, take your time, and then turn it back on again. Okay. So the first concept is corresponding angles are equal. Okay. Corresponding angles are equal. So if you look at the screen here, I've got angle one. Corresponding means, okay, I'm going to circle angle one here. Here's angle one. It corresponds. I'm not talking about vertical from it. 4 is a vertical angle from it, and 4 and 1 are equal. Corresponding means one way to look at it, which you might see in your math book if you look this. If I divided these two things up here, these two sections up, and if I took everything here that I'm putting inside this box, and if I literally kind of cut it out and set it on top of everything that is up here, okay, if I set them on top of each other, you would see that they match exactly. That 5 and 1, angle 5 here, would sit right on top of 1, and it's the exact same. Okay, 6 and 2 would be the same. Okay, so that's what we mean by corresponding angles. I know now it's a little confusing because I've got lines all over the place, but if you look at the far right here, where I'm pointing my arrow, angle 1, okay, corresponds with, okay, we're not talking about vertical or supplementary, we're talking about corresponds with angle 5, and they're equal to each other. They're the same amount of degrees. Angle 3, okay, I'll circle angle 3 here, corresponds with, okay, where is it? It corresponds with angle 7. Okay, so these two angles are corresponding. And if you kind of look at them, you'll see they're the same amount of degrees. And angle 2 is corresponding. This 2 here corresponds with angle 6, which would be this one right here. Okay, and you'll look at them. If you actually look at the way they look from here to here and from here to here, yeah, they look like they're the same amount of degrees, and they are. And then finally, angle 4, this one here I'm now circling here, it corresponds with angle 8, which is down here. Okay. So corresponding angles are equal. That's the concept we need to get in our mind. They mean they're the same. So what that means is, let's look at angle 2. It's still at the top of the page here. If I told you that angle 2 was 60 degrees, what do I now know about angle 3? Well, from the last slide, we know that they're equal, so 3 is 60 degrees. If 2 is 60 degrees, look down at angle 6. It's the corresponding angle. It's 60 degrees. That means, listen to this. If I know that 2 is 60 degrees, I can look down all the way down to 7 and know that it's 60 degrees, okay, as a corresponding angle. So I can figure out all those just by being given one, and actually I can figure out all of them, okay? All right, this next concept is called interior. We've got this alternate interior angles. They are equal. Alternate interior angles are equal, okay? And if you look at my little post-it note on the bottom left-hand side of your screen, I've got a note that says interior means they're angles that are inside or inside the two parallel lines and on the opposite sides of the transversal. Okay, so if we look at my example here, I've got angle 3, 4, 5, and 6, right? Angle 3 is equal to angle 6, all right? So those are my alternate interior angles. 3 is equal to 6. Um, and that means that they are angles that are inside the two parallel lines. You'll see that, you see that 3 and 6 are both inside the two parallel lines here. Here's my lines, and they're both on the inside of it, okay? So that's what it means. Alternate interior angles are equal. Now, some of you might right now be going, teacher, how am I going to remember all this? I'm going to have a little secret, a little quick way to remember all this. So hang in here. Don't stress about this. Okay, I've got a way to make this easy for you. It's coming real soon. Okay. All right. Next slide. And it's another concept that's similar. And again, I want you to stop the video, and I want you to copy this down. Okay, I'm going to jump back into things. Alternate exterior angles are equal, okay? And exterior, these are angles that are on the outside or exterior of the parallel lines and on the opposite alternative side of the transversal. Doesn't it sound like I'm speaking another language? All right, let me make it easier for you, okay? Angle 1 over here, this angle 1 I'm circling. Alternate exterior means they're on the outside of the two parallel lines. So I've got my A line and my B line. They're above or below it. They're not on the inside, okay? That's what it means, alternate exterior. So angle 1 here is equal to angle 8. They are outside exterior of the parallel lines, and they're alternate, so they're equal. And angle 2 is equal to angle 7. Okay, so that's what that rule means. Now, here's my shortcut that I promised you guys was coming here. All right, the four acute angles, remember acute means less than 90, are all equal. Okay, that's all you have to remember. I mean, that's one thing. They're all going to be equal. The four acute angles are all equal. I'm gonna like put a little star by all the acute angles here. Okay, this one's less than 90 degrees. This one's less than 90 degrees. Where else are there acute angles? There's one right here. There's a star there. That's an acute angle right there. And what is my other one? It's right here. Okay, all four of these are all acute, and they are equal to each other. Okay. All right. So you can remember the four acute angles are all equal, and the four obtuse angles are also all equal, which means one above is equal to, it's, remember, obtuse. If this is 90 degrees and it's more than 90, it's more than 90 here, then it's obtuse. One is equal to what? One would be equal to, now I've made it confusing, 8, and there'd also be equal to, let me put squares by these ones here. This one would be equal to 1, okay? Remember, 1 is this bigger angle that goes all the way across here, okay? So all four of those obtuse angles would be equal, okay? So, and then the last thing I want you to remember, I'll put a little star down here, is each acute angle is supplementary to each obtuse angle, okay? And so what that means is if I took, if I just take a little quick drawing here like this, okay, each acute angle is supplementary. So if this is 60, okay, then it is supplementary to whatever this is, okay? And 60 from 180 is 130. But that's all that's saying, is that if you're given one acute angle, you can figure out what the one next to it is, okay? All right, moving on to the next slide, last slide. Okay, why don't you go ahead and copy down this slide. I'll pause for 5 seconds. Okay, I'm going to jump into this. Example problem. Parallel lines E and F are cut by a transversal. Okay, so here's lines E and F cut by a transversal. The acute angle at the upper right is 50 degrees. Label others, wow, that should say 7, Seven. Okay, the other 7, this is 7. I'll just make this simple here. Label the other 7 angles, okay, in the figure. So here's how you would figure this out. So the one in the upper right-hand corner is 50 degrees. Okay, step 1 is label the acute angle in the upper right-hand corner. So we put a 50 degrees there, okay. Step 2 is label all the other acute angles. Because remember, we learned when we have 2 parallel lines crossed by a transversal, all the acute angles are equal. All the obtuse angles are equal, okay. So we can label all the other acute angles. Okay, because it wants to know what are all these other angles. You know, it might have letters by each of these angles. This might be angle A. Might be angle B. This might be angle C, D, E, F, and G and H. Okay, so it might ask you, okay, give the degrees. What is the measurement of all these angles? Okay. Well, 50 is vertical to the C, angle C here. So D and C are vertical. Okay. That means that this is 50 degrees right here, this angle here, which is F. And that means that G is 50 degrees. Okay. All right. Now, can you figure out now that we know that 1, 2, did we leave one out? 3, 4. Yeah, we've got 450. So can we figure out what A, D, E, and H are? Okay, here's the math. We're going to take 180 degrees because 50 is a supplement. This angle 50 degrees here is a supplement to angle A. So we're going to take 180 degrees because the supplements add up to 180. We're going to subtract 50. We're just going to do the math here, and you're going to get 130. Okay, that means that A is 130 and D is 130 because remember they're vertical from each other. E is 130. This is looking kind of confusing now. And H is 130. We now are able to label all of the angles just by being given one angle. Okay. All right. At the end of this session, I want you to complete all the problems on pages 31 through 33. And then just to give you the heads up, my next session will be a review for your first test. So you do not want to try that test until you've done 2 things, all the homework that I've given you so far, number 1, and number 2, you have watched carefully and taken good notes on my review session, which is coming next, so that you will be prepared and will do really well on the first test.